Hello everyone, this is Abhita Sunkara. Welcome back to our Enterprise Data Engineer interview series. So, today interview question is, what is the difference between a data lake, data warehouse and lakehouse? So, which architecture would you recommend in a production environment and why? So, this is one of the most common architecture questions in interviews for Azure data engineers, Snowflake developers, Databricks engineers, and solution architects. So many candidates simply memorize definitions, but experienced interviewers want to know why these architectures exist, when to use each one, and how they work together in a real enterprise. So let's understand this using a real production scenario. So, let's imagine we are working for a large retail company with thousands of stores, an e commerce website, a mobile app, or LOT devices, and several third party vendors. So, every second, data is being generated from different sources. So, the billing system generates structured transaction data. Then, the website produces clickstream logs. Then mobile applications send JSON events and LOT devices continuously generates sensor data. Then customer support uploads PDF documents and images. The company also receives data from external partners. Now, the business asks you to build one enterprise platform where all this data can be stored, processed, analyzed, and used for reporting and machine learning. So, at first glance, we may think one storage solution is enough, but different data types have different requirements. Raw data needs flexibility, and business reports require highly optimized structured data. So, here, AI and machine learning requires massive historical data sets. So, this is why modern enterprises use data lakes, data warehouses, and now lake houses. So, each architecture solves a different business problems. Then, now understand where each architecture fits inside an enterprise platform. So everything starts with operational systems like ERP, CRM, or banking applications, or LOT devices, or APIs, and third party systems. So the first destination is usually the data lake. So the data lake stores raw structured, semi structured, and unstructured data exactly as it arrives. Nothing is lost. Then nothing is forced into a predefined schema. From there, transformations begins. So cleaned and business ready data is loaded into the data warehouse. So the warehouse follows schema on right, which means data is modeled before it is stored. So this gives us fast SQL queries, dashboards, and reporting. Now let's talk about the Lakehouse. So the Lakehouse combines the flexibility of a data lake with the performance and reliability of a data warehouse. It stores raw and curated data together using open table formats like Delta Lake, Apache Iceberg, or Apache Hudi. So finally, Power BI dashboards, business users, data scientists, and AI models consume this data. So instead of competing with each other, these architectures complement each other. Now let's follow the journey of a customer order. A customer places an order through the company's mobile application. So the transaction is captured by Azure Data Factory or Kafka. So the raw event first lands in the data lake. So nothing is modified here. Then this allows us to preserve the original source data. Then next transformation begins. After that, data is validated, cleaned, and duplicates are removed and business rules are applied. So if the company follows a traditional architecture, the transformer data is loaded into the data warehouse. Then business users now access reports and dashboards from the warehouse. So if the organization uses a lakehouse architecture, both raw and transformer data sets remain inside the same platform. So delta tables provide ACID transactions while still supporting scalable object storage. So machine learning models can directly access historical data without creating additional copies. So this reduces storage duplication, improves performance and simplifies the overall architecture. Now, this is where interviews usually check your real production experience. For data lakes, always use open file formats such as Packwit, ORC or Evro. Organize data into bronze, silver and gold zones. Then implement partitioning to improve performance. Also maintain metadata using a data catalog. Then apply lifecycle management to archive or delete old data. After that, for data warehouses, always design the dimensional model before loading data. So use star schema whenever appropriate. Then optimize queries through partitioning, clustering, indexing and materialized views. Also maintain strong governance and auditing. For lake houses, use open table formats like Delta Lake or Apache Iceberg. Enable ACID transactions, then support schema evolutions. Optimize files using compaction and Z ordering where applicable. Implement unified governance with tools such as Unity Catalog or Microsoft Purview. So, across all architectures, security is equally important. Then encrypt data, implement role-based access control, maintain lineage and monitor costs, automate pipelines and continuously validate data quality. So the biggest mistake when I see in organizations treating every workload the same. So different workloads require different architectures. So now we are in the interview section. So explain the difference between data lake, data warehouse and lakehouse. So this is how our answer would be. A data lake stores structured, semi-structured and unstructured data in its native format. It supports schema on read and it's best suited for raw data storage, machine learning, data science and historical archives. Then a data warehouse stores structured, cleaned and modeled data optimized for SQL reporting dashboards and business intelligence. It follows schema on write and provides high query performance with strong governance. After that, a lakehouse combines the strengths of both architectures. It stores data on low-cost object storage while supporting ACID transactions, then schema evolutions, SQL analytics, streaming, and machine learning using open table formats like Delta Lake. So in production, I don't view these architectures as competitors. I select the architecture based on business requirements. If the requirement is raw scalable storage, when we choose a data lake, then if reporting performance is the priority, then we have to choose data warehouse. If the organization needs one unified platform for analytics, AI and streaming with lower storage costs, then we have to recommend Lakehouse because it combines flexibility, governance and high performance. That's how we have to answer like a senior level interviews. Now, here are few practical tips from my experience. So don't recommend one architecture for every project. Understand the business use case before choosing a platform. Data lakes are excellent for raw storage and exploration. Data warehouses remain the best choice for highly governed BI reporting. Then lake houses are becoming the preferred architecture because they support analytics, streaming and AI in one platform while reducing data duplication. So that brings us the today's end of today's episode on data lake versus data warehouse versus lake houses. So the biggest takeaway point here, a data lake stores everything, a data warehouse optimizes business reporting, and a lake house combines the best of both worlds into one modern scalable platform. If you found this video helpful, please like, share and subscribe to the channel. So don't forget to press the notification bell so you never miss our upcoming enterprise data engineer interview series. Thanks for watching, and I will see you in the next episode where we will discuss Delta Lake architecture. Thank you.